Hi, just a quick announcement. I've changed a few things besides my haircut, and what it basically means is that I consider working on this project my job now. I'm doing other work to earn money, obviously, because I can't live off that yet. In fact, if you want to hire me, just send me a message or something. But what it means for you is that you can expect more videos in the near future. I'm not a man of many promises, I'm just doing what I want to do, and I want to do this. So let's dive into it, and I will show you where I am and solve a practical problem that I'm facing right now. I'm going to fix an annoying bug in the keyboard driver, which is that sometimes it does not get the key right. So I'm now hitting plus to increment that byte, but sometimes it doesn't read it as the plus key but as another key. So yeah, now it just hangs. If I press plus again, it doesn't work, and I can try another key, for example right arrow, but it took this for a page down now, and now everything seems to work again, and I can try this. It already did it again. Yeah, I can also hit right arrow, and sometimes it takes it as a 6. So I'm just scrolling through the memory here, and sometimes it will just drop a number 6 in there. It's kinda rare, it doesn't happen very often, but it's still annoying. Come on. There it happened. It made a 6 instead of moving to the right. So I'm going to fix that today. Okay, this is what the signal from the keyboard looks like. You have a clock signal and a data signal, and on the falling edge of the clock signal the data is valid. So there are 11 bits, a start bit, 8 data bits, parity bit, and a stop bit. They don't fit all on the screen here. But what I'm doing is I have an interrupt on the falling edge of this signal, and I'm reading each bit in, and the code keeps track of where it currently is, if it is reading data or parity bit, and if one key has been received, it then stores it in a 1-byte buffer where you can look up what the pressed key was. So what I think the problem is the timing of the interrupt. So if I'm looking at when the interrupt is running, so I'm going to output a debug signal that I turn on when the interrupt starts and I turn it off when the interrupt ends. What should be happening is this, that after the falling edge, the interrupt immediately fires, takes very short time to process one bit, and then it goes on. And after the next falling edge, it fires again, and so on. One thing that could be wrong is that sometimes there's something else stopping it from occurring, maybe another interrupt taking too long, so that this gets delayed. Maybe until here, and then the data is not valid anymore. And it could even happen that the next one gets lost. So you have a too long delay from the falling edge to the interrupt occurring, and then you miss the next one. It could also be that the interrupt itself takes way too long, so that there's very little time between interrupts, so that if there's the slightest delay in here, they start to overlap, and they won't overlap, obviously. If this one takes too long, this one will get lost. That's what I think the problem is. I'm gonna hook up the scope, and I will monitor the clock signal and my debug signal and see what's happening. And obviously it's not always happening, so I hope that my scope is good enough to catch that glitch. So this is what the signal looks like. It's just perfect. In fact, the bug has gone away now, and I already know why. So let's look into it. This is the interrupt occurring. As you can see, there's a quite substantial amount of jitter, but it's always short and in time. What's happening here is that I'm now running the code from RAM, and RAM can read much faster than the flash ROM, and when the bug happened I was running the code from flash ROM, and by default the flash ROM is set up so that it can handle the maximum CPU frequency of 50 MHz, and I'm currently running at 10 MHz, so the flash ROM is not only reading slower than RAM, but also 5 times slower than it could read. So I'm going to program this version of the code to the ROM now, and then look at the signals again. Okay, now I got the code in ROM, and if I hold a key, it starts jittering all over the place. In fact, if we zoom in now, we can catch a really bad one. Just try a few times. Yeah, like this. As you can see here, the interrupt is happening way too late. I'm looking at the interrupt vector sources by priority now, and the interrupt that gets delayed, which we saw in the scope, was a pin interrupt on port A, and there must be another interrupt that has higher priority that stops this from executing immediately. In fact, it's the SPI interrupt. It's the only one I'm using right now, except for the pin interrupt on port A, and it has a lower priority number here, which means that it has higher priority. So whenever both of them occur, SPI gets served first, which is not what I want. In fact, the SPI interrupt can wait, well, as long as it has to, because the EZ80 is the master on the SPI bus, and the interrupt just signals when the transmission is complete, and nothing bad happens when we wait for... Nothing bad happens if the interrupt gets executed later. It's just used to avoid busy waiting for when the transmission has finished. The pin interrupt, however, needs to be executed immediately, as we saw, because we're catching bits here from a signal where the clock is generated by an external device, the keyboard. So what I need to do is increase the priority level of the pin interrupt, and there are interrupt priority registers here, and here there are interrupt vector priority control bits, and if you set that bit for an interrupt, it gets boosted up by 1 level. So if you put it on level 1, then it comes before all level 0 interrupts. That's what I'm going to try now. Okay, I'm now looking at the signal again. This time I've enabled persistence mode, so that we can see if there are any cases where the interrupt gets delayed, but this does not happen anymore. There's still a little bit of jitter in there, but the long delay where the interrupt is way too late does not happen anymore. Okay, I've had it running for several minutes now, and as you can see, there's not a single occasion where the interrupt is too late. You can see the jitter, but as you can see by the red line here, that in most of the cases it happens immediately, but sometimes it gets delayed a little bit because, well, there might be another interrupt running right now. I don't use nested interrupts. So, yeah, but that's acceptable. So, the problem is fixed now. But as you can probably remember, I said that it first happened when I moved the code to ROM, and the reason was that the ROM is reading slower than it could, and so the code is executing slow, and this is what also made the delay between interrupts so big that it caused a problem. Why didn't I just increase the speed at which the ROM reads to fix the problem? Well, because I saw that the time available is actually enough. It's just the delay or the order in which things happen. I could have solved it by just doing the wrong thing faster, but I thought doing the right thing is better, so I don't even have to increase the speed, and this makes the software more robust. Maybe someday someone uses an external memory with my computer that is slow, and that may cause the keyboard driver to fail, which is, well, bad. So this is basically why I'm doing the project in the first place. I want to understand how things work, and using limited resources enables you to, well, solve problems the right way, not just by throwing more memory, more CPU speed added. Yeah. Okay, that's it for today. And next time I will show you the things I made in software and how you can play around with the machine code now, and it's quite a lot of fun. So stay tuned. Bye.